Hello, welcome back to my channel, and in this video we're gonna talk about what it even mean by the universe. There are different way, observable universe and everything else. So let's see the difference. So when people say the universe began at the Big Bang, what do they actually mean by the universe? Because it turned out the word doesn't always mean the same thing. What is the observable universe? When astronomers talk about universe, they usually mean the observable universe. That's the part of the universe from which the light had time to reach us since the beginning of cosmic expansion. That this region is finite, even if the universe as a whole may be infinite. So when you hear the universe was very small at the Big Bang, what really means is the observable universe was very small. So if you look at this picture, you can see inside the pink circle, you can see it, yes. Can you read it? Yes, in principle. Between pink and yellow, you can see it, but we cannot reach it. But outside the pink, you can't see it and you can never reach it either. So, was the universe infinitely small? You might hear that the universe was infinitely small at the Big Bang. That could be only true if the universe is finite today. But current evidence suggests the universe may be infinite in extent. If this infinite now, if it's infinite now, it was infinite then too, just much denser everywhere. So the difference between finite and infinite here is mostly semantic. What matters physically is this: the region we can observe today grew out of a very tiny region in space. Astronomers focus on what they can observe, but cosmologists sometimes go further. They consider model where observable universe is just a small part of much bigger, larger system. In this context, you will sometimes hear the word multiverse, meaning many disconnected regions that can never communicate with one another. Important point, we can never directly test anything beyond the observable universe. So physics stays grounded in whether a model gives consistent history for the point of universe we can actually see. In this picture, the Big Bang is not necessarily absolute beginning of all existence. Instead, it marks the beginning of rapid expansion of our region of space. The rapid expansion is called inflation, and everything we can test measure begins after inflation ends. Whether the universe is filled with hot, dense matter or radiation. Everything we can test and measure began after inflation ends. When the universe is filled with hot, dense matter and radiation, anything before that is beyond experimental reach. Interesting but not a testable sign. But can we run the clock backward? But as we run the clock backward, the universe becomes denser, hotter, and more energetic. Very close to the Big Bang, density exceed 10 to the power 90 gram per cubic centimeter. Temperature exceed 10 to the power 32 Kelvin. At those extreme conditions, particle collisions are so energetic, gravity becomes as strong as other forces. Our current theory do not work there. So physics can't describe a definite starting movement. Even though we don't know the exact beginning, it doesn't stop us from doing science. Because very quickly the universe cools, density drop, and the condition becomes such that you can describe by the non-physics. At that point, particle and radiation reach thermal equilibrium. Energy is evenly shared. The universe becomes hot, dense, uniform plasma. This is where reliable cosmology began. After just the Big Bang, the was hot, dense, nearly uniform, filled with particle and radiation. Collision happens so frequently that everything shares a common temperature, like gas mixed with sealed containers. A simple, well understood state is the starting point for matter formation, antimatter annihilation, the cosmic history we can test. This is exactly where the mystery of missing antimatter begins. So, in the end, when we talk about the universe, we usually mean the observable universe, not necessarily everything that exists. Big Bang isn't the creation of space at a point, it's the beginning of expansion of a region we can observe. The universe may be bigger than we can ever see, but everything we know began in hot dense state we can still study in the sky today.